Well, hello, amazing people, students, lovers of chemistry, and all my supporters on this channel out there. I'm super excited to be here with you on this video where we get to handle the limiting reagent or the limiting reactant in stoichiometry. My name is David, and I'm an online chemistry tutor for high school kids. I'd like you to sit back, relax, and enjoy every bit of what I've got coming for you on this channel. So let's see if we can learn a thing or two from this video. We start off by defining what the limiting reagent or the limiting reactant is. So basically, what is a limiting reagent? A limiting reagent is also known as a limiting reactant, and it is simply the reactant that gets used up first in a chemical reaction. So now, when chemical reactions happen, we have a scenario going on. We have the first reactant, let's say it stands as A, reacting with the second reactant, let's say it stands as B to produce a product. Now, in the process of this reaction happening, it is possible for one of the reactants to get finished up while the other one still remains. Now, when that happens, the substance that gets finished up first is called the limiting reactant or the limiting reagent because it is the one that limits how long the reactant or the reaction can go. Now, because the limiting reactant is the one that finishes first, therefore it is the one that determines how much product can be formed and when the reaction stops. So basically that's what the limiting reactant is all about. So let's check out some examples on the screen. Now you have this equation on the screen. The equation says 1 mole of nitrogen requires 3 moles of hydrogen. You can see from the equation we have nitrogen N2 and we have hydrogen 3H2. If we extract the coefficients, we have 1:3. What this simply means is 1 mole of nitrogen requires 3 moles of hydrogen. So now we went further to say, imagine we have 1 mole of nitrogen available and 10 moles of hydrogen available. The equation says 1 mole of nitrogen requires 3 moles of hydrogen. Now, when the reaction wants to happen, they said imagine we have 1 mole of nitrogen and 3 moles of hydrogen available. The question is which reactant will run out first? Well, the easy thing to do would just simply be to assume that there is one of the reactants that we do not know is available, so we can obtain the number of moles that we need and then we compare it. Now watch what I'm going to do. So under nitrogen, I would simply say 1 mole of nitrogen N2 will require X moles of hydrogen. I want to find out the number of moles of hydrogen that will be needed and then I compare it to what I have available. So if I cross multiply, I have 1 times X being equal to 3 moles. So X is equal to 3 moles of hydrogen. But watch this now. It means we need 3 moles of hydrogen, H2. But what do we have? But we have 10 moles of hydrogen. We need 3 moles, but we have 10 moles. So it means hydrogen is in excess or it is too plenty. Automatically, that means nitrogen here is the limiting reactant. So to answer that question, which reactant will run out first? That will be nitrogen N2. So can you see how the limiting reactant was identified? So now let's go into the meat of today's video. You might be thinking, how do I know which reactant is limiting? How do I know which one is the limiting reactant? Well, there is a simple method to do that. Step number 1 is to write the balanced chemical equation. Write the balanced chemical equation. Step number 2 would be to convert all given masses into moles if that is necessary. Step number 3 would be to compare what you have with what the equation requires. And step number 4 would be the reactant that produces the smaller amount of product is the limiting reactant. Don't worry, we're going to be taking all this step by step so you can see exactly what we mean. So step number 1 would be to write out the balanced equation. Obviously, that has been done for us already. You can see the balanced equation written over here. Step number 2 would be, well, let's backtrack a bit to see what step number 2 says. Step number 2 says convert all given masses into moles, where we're not given masses, so that's not necessary. Step number 3 would be to compare what we have with what the equation requires. So let's go ahead and check out what the equation requires, and that comes by the mole ratio. So you can see from the equation we have 2H2 and O2. What this simply means is that we have 2:1. So in simple English, this means 2 moles of hydrogen requires 1 mole of oxygen, O2. So this is what the mole ratio is. Now we've gotten what the equation requires. So let's see what we have on ground. Now this question says, suppose we have 4 moles of hydrogen and 1 mole of oxygen. Now between these two, one is in excess and one is in short supply. How do we know? Well, let's assume the number of moles for hydrogen is unknown. We can do the same for oxygen, any one of these two. We can assume the number of moles of hydrogen is unknown or the number of moles of oxygen is unknown. Why? Because we want to find out the number of moles of the two of them that will be needed, and then we'll compare it with what we have. So under this part for hydrogen, I'll simply say X moles of hydrogen, H2, will now require 4 moles, or 1 mole, I beg your pardon. Let's write that out. 1 mole of O2. You can see over here we have 1 mole of O2. So we're assuming we don't know the number of moles of hydrogen that we need. So let's cross multiply. When we cross multiply, we have X times 1 is equal to 2 times 1. This gives us 2 moles. So what this simply means is that 2 moles of hydrogen are needed. But what we have on ground, but we have how many moles? You can see 4 moles. So it means that hydrogen is in excess, and that automatically means oxygen is in short supply. So to identify the limiting reagent is oxygen, which is in short supply. Can you see that we can identify the limiting reaction from questions like this? Let's handle another example. The second example on the screen where we'll be identifying the limiting reaction is given right now. From the equation, step number 1, we get the mole ratio after we've written the balanced chemical equation, of course. Now from the equation, you can see N2 is reacting with 3H2. So that leaves us with the mole ratio of 1, 2, 3. Okay, what this simply means in English is 1 mole of nitrogen, N2, reacts with 3 moles of hydrogen, H2. So let's assume we do not know the number of moles of nitrogen that are needed. So let's see how many moles of hydrogen or nitrogen will be needed to react with 9 moles of hydrogen. So under here, write X moles of nitrogen will be needed to react with 9 moles of hydrogen. So at this point, I simply cross multiply. So I have x times 3 being equal to 9 times 1. So this gives me 3x being equal to 9. X is equal to 9 divided by 3, which is 3 moles. So what this means is that 3 moles of nitrogen are required. Now 3 moles of nitrogen are required, but what do we have? We have only 2 moles of nitrogen available. So it means that nitrogen is not enough, or it is in short supply. So that automatically means that nitrogen is the limiting reagent. So can you see how the limiting reagent was identified? So let's move on in this video. So when questions that involve solving limiting reagents comes in, okay, when the calculations become bigger, use this method. What's the method? Convert each reactant into the amount of product it can produce. The reactant that produces less product is the limiting reagent. Don't worry, we are going to apply this. Convert each reactant into the amount of product it can produce. What does that mean? It means for each reactant, we are going to get the amount of products. We're going to get the amount of products that it can produce. So that means we're going to get the amount of products that each reactant can produce. The first reactant is nitrogen. We'll obtain the amount of products it can produce, and we'll do the same for hydrogen. Anyone that produces the less is the limiting reactant. So let's apply that into this question. So from the question now, you can see we have the first reactant, which is nitrogen. So let's compare, or let's equate nitrogen with the products now. We have N2 and 2NH3. That's the products. The mole ratio becomes 1:2. That simply means 1 mole of nitrogen produces 2 moles of ammonia, NH3. Okay, so now let's see the amount of product that it can produce. From the question, we see what's available. So we have 1 mole of nitrogen. So we come down here and say 1 mole of nitrogen produces X moles of ammonia, NH3. So when we cross multiply, we end up having X equal to 2 times 1, which is 2 moles basically. So what this simply means is that this 1 mole of nitrogen produces 2 moles of NH3. Let's keep that aside. Now let's find out how much product this guy can also produce. Anyone that produces less becomes the limiting reactant. So from the equation, you can see we have 3H2 and 2NH3. So that gives us the mole ratio 3:2. What this means is 3 moles of hydrogen produces 2 moles of ammonia, 2NH3. So now we have 4 moles of hydrogen. So therefore 4 moles of hydrogen produces X moles of ammonia, which is NH3. So at this point, we simply cross multiply. So we have 3x, or 3 times x is basically equal to 4 times 2. So 3x is equal to 8. So x is equal to 8 divided by 3. 8 divided by 3. Allow me to punch my calculator for a moment. 8 divided by 3. 8 divided by 3 gives me 2.6. 8 divided by 3 gives me 2.6. 2.6 moles of NH3. So what this simply means is 1 mole of nitrogen produces 2 moles of NH3, while 4 moles of hydrogen produces 2.6 moles of NH3. Now the question is, between these two guys, which one is less? Of course, this one is less. So the limiting reactant is nitrogen. So what we simply did was to find out how much product each reactant can produce. We found out how much product nitrogen can produce. We found out how much product hydrogen can produce. The one that was less gave us the limiting reactant. Don't worry, we'll handle yet another question. So here is another question on the screen. We're given this equation and what we have available is given in masses. Before we do anything, we'll first convert into number of moles. So number of moles N is equal to the mass of a substance divided by the molecular mass. For magnesium, the number of moles becomes 48 divided by 24. The molecular mass of magnesium is 24 and the mass of magnesium given here is 48. So we have 2 moles. So let's write that out. For magnesium, we have 2 moles. How about for oxygen? The mass divided by the molar mass. The mass of oxygen is 48. The molar mass for oxygen is 32. O2 is given as 16 times 2. Okay, so 48 divided by 32. Give me a moment to punch my calculator. 48 divided by 32. That's 1.5. So I have 1.5 moles. Alright, so oxygen, 1.5 moles. The next thing to do at this point would be to use this information to find out how much products each reactant can produce. How much products each reactant can produce. Let's do that very quickly. So for magnesium, we have 2 mg. And for the product, which is magnesium oxide, we have 2 MgO. Alright, so this simply gives us the mole ratio 2:2. This can be broken down to become 1:1. The meaning of that is 1 mole of magnesium reacts to produce 1 mole of magnesium oxide. So therefore, we know that from the question, we've converted these 48 grams of magnesium to become 2 moles. So it therefore means 2 moles of magnesium will react to produce X moles of magnesium oxide. So if we cross multiply, X will be equal to 2 moles of magnesium oxide, MgO. So we found out how many products or how much product these 48 grams of magnesium can produce. It can produce 2 moles of magnesium oxide. Now let's find out. Let's find out for oxygen and see how much product it can produce. So oxygen, O2, reacts to produce 2 MgO. So the mole ratio becomes 1:2. What this means is 1 mole of oxygen reacts to produce 2 moles of magnesium oxide. Now from the question, we know that this is equal to 1.5 moles. Okay, 1.5 moles. Remember, magnesium here produced 2 moles of magnesium oxide. Okay, so let's just keep that aside. Now we have 1.5 moles of oxygen produces X moles of magnesium oxide. So we just simply cross multiply. When we cross multiply, we have x times 1 equal to 1.5 times 2, x is equal to 3 moles. That's the number of moles of products that oxygen can produce. So let's write that data out. First, we have magnesium produces 2 moles of magnesium oxide and oxygen produces 3 moles of magnesium oxide. Which one is less? From the two of them, you can see that the lesser one is this guy. So therefore, magnesium is the limiting reactant. So can you see how that was done? The first thing we did was to convert into moles. Then we found out how much product each reactant can produce. The one that was less gave us the limiting reactant. Pretty easy and straight to the point. So a quick summary of all we've been saying since the commencement of this video is the limiting reactant is the one that is used up first. It determines how much product can be formed. Reactions stop when the limiting reagent runs out. Balanced equations provide the necessary mole ratios, and make sure you always convert the masses into moles when necessary. And then finally, the reactant producing the smaller amount of product is the limiting reagent. I trust you got so much value from this. If you did, please consider subscribing, sharing, and liking this video. Alright, so here are some practice questions I'd like you to try out your hands on before we move on to the next thing in this series. So we have the first section. Feel free to pause this video and write out the questions so you can answer them. Drop your answers in the comments where I'd be waiting to respond to each and every one of them. So, up until now, we've done a whole lot. In our next video, we're going to be talking about the opposite side, which is the excess reagent. I trust you got value. If you did, once again, please consider liking, sharing, and subscribing to this YouTube channel. Up until I come your way next time, my name remains David, and I'm an online chemistry tutor for high school kids. I'll see you in the next video. Stay blessed.